Some of them paddled out and never came back. Not because they died, because the wind changed. 50,000 years ago, the coastlines of Southeast Asia looked nothing like they do today. Sea levels were lower, islands that are now underwater were dry land, and the gaps between them were real but crossable. Small groups of people were moving through this world, not exploring in any grand sense, just following food, following coastlines, following the logic of what they could see from where they stood. The key word is visible. If you could see the next island from the shore you were standing on, the crossing was possible. If you could not see it, almost nobody tried. The watercraft they used were simple enough that none have survived. Logs tied together, a hollowed trunk, materials that rot completely within a few decades, leaving nothing for archaeologists to find. That absence of evidence is itself the evidence. We know they crossed because of where their descendants ended up, not because they left any boat behind. Twice a year, the entire wind system over Southeast Asia reverses direction. The monsoon. In one season, winds push steadily from the southwest, in the other, from the northeast. For a raft with no sail and limited paddles, that difference is everything. A group sets out in the right season. The wind is behind them. The current helps. A crossing that might take 2 days by paddle alone takes half that. They reach the island. They land. Then the season changes. The wind reverses. The current reverses. The same stretch of water that carried them here now pushes back against any attempt to return. A raft with paddles cannot make headway against a sustained monsoon wind. They could see where they came from. On a clear day, the old island was still there on the horizon. But seeing it and reaching it were now two entirely different things. It was not just wind. Surface currents in this region run in seasonal loops. Miss the window and the ocean itself becomes a barrier more effective than any wall. Nobody was coming to find them. There were no other boats, no signal fires that anyone would see. Whatever this island had to offer, that was now their entire world. The strandings left a record, not in stone or bone at first, but in genetics. When a tiny group founds a new population and never mixes with outsiders, their DNA carries a very specific fingerprint. It is called a founder effect. When only a handful of people start a new population, the genetic diversity of everyone who comes after them is limited to whatever those few individuals happen to carry. Across the Western Pacific, genetic studies of ancient populations show this pattern repeating on island after island. A founding event, a small group, then centuries of isolation before the next arrival, if one ever came. Some of these groups were isolated for hundreds of years before any outside contact, long enough for the population to develop its own distinct genetic profile, separate from every other group on Earth. Modern researchers comparing ancient DNA from island burial sites to mainland populations can identify exactly when these founding events happened and roughly how many people were involved. Sometimes the number is startlingly small. In some cases, the genetic evidence points to founding populations of fewer than 10 individuals, possibly as few as 3 or 4. An entire island lineage descending from one small family that could not get home. Genetics is one record. Bones are another, and the bones found on certain isolated islands tell a story that genetics alone cannot, the physical cost of being cut off. A small island is not a generous place. The diet available to a stranded group was whatever grew there, whatever swam in the reef, and whatever birds nested on the shore. That is a narrow menu for a lifetime. Teeth record nutritional stress as they form. Periods of food shortage leave permanent horizontal lines in the enamel called hypoplasia. On isolated island populations, these lines appear earlier and more frequently than in mainland groups. Inbreeding leaves its own marks. Certain skeletal anomalies, unusual jaw formations, extra bone growths, asymmetries, appear at higher rates in populations where the founding group was very small and no new people arrived for generations. Flores Island in Indonesia is one of the clearest examples. Populations there show skeletal evidence of prolonged isolation, stress markers, morphological clustering, consistent with a founding group that arrived and then stayed, separated from the wider human world. The people who showed the worst stress markers were not the ones who made the crossing. They were the grandchildren, the ones born into the isolation, who had no memory of anywhere else and no way to leave. Here is the thing that changes how you see all of this. The strandings were not accidents that interrupted the migration. They were the migration. The Pacific was settled largely by people who could not get back. The person who decided to get on the raft knew the island was there. They probably did not know that the wind would change before they could return. That knowledge came later to the people who stayed. For most groups, coastline hopping was ordinary, a short crossing to fish, to trade, to visit. The possibility of being stranded was a risk they managed, not a fear that stopped them. Most crossings worked fine, but some crossings did not work. The wind changed, the current ran wrong. And a group that set out for a day trip became the founders of an entirely new population, whether they chose that or not. Within a few generations, that stranded group became a community. Within a few centuries, a distinct population. Their descendants are still on those islands today, carrying the genetic record of a crossing that went wrong in exactly the right way. The wind did not care about their plans. The current did not make exceptions. But every island in the Western Pacific with a human history has one of these moments at its beginning. A raft, a changed wind, and a group of people who had to figure out what came next. Human beings did not spread across the Pacific because they were bold explorers with a plan. They spread because some of them got on a raft. The wind changed, and they made the best of where they ended up. That is most of human history, really. If this changed how you think about early humans, subscribe. There is a lot more where that came from.